Hi there, coding enthusiast. Welcome back to my channel. I'm your host Alok, and today we have got a sorting spectacle for you. The name of the spectacle is Quick Sort, and by the end of this video, you will have a proper understanding of Quick Sort. So, in this video, we will define what is Quick Sort, how it works, how to code it in Python, and at the same time, we'll be exploring the time complexity of this sorting algorithm. So, let's get started. But before we dive into this sorting madness, make sure to hit that subscribe button and ring the notification bell, as it will motivate me to come up with more such amazing videos for you. Alright, let's kick off by defining the rockstar sorting algorithm. So here is the bookish definition of quicksort. Quicksort is a highly efficient, comparison-based sorting algorithm that employs a divide and conquer strategy. We'll talk about divide and conquer strategy in the upcoming slides. But first, get familiar to the common terms used in quicksort sorting algorithm. Here is the working. It works by selecting a pivot element from the array. The array that will be having, it will be selecting a pivot element from the array and partitioning the other elements into two sub-arrays. Suppose a pivot has been taken, and around that pivot, left side and right side, two sub-arrays would be gathered around that, sorting them recursively. It is a recursion-based sorting algorithm. It has an average time complexity of big O of n log n. So now let's understand it with the help of an example. Suppose you are at a party and you are the party organizer. Your task is to arrange the guests according to their dancing skills. So here are the guests from A to H, and you have to arrange them according to their dancing skills in increasing order. And this is the report which contains the dance skills ratings. So 1 to 8 ratings have been given. So now let's arrange them by quicksort intuition. As we know, in this sorting algorithm, we need a pivot. I can either take this as my pivot, or I can take any of the middle element as my pivot, or the last element as my pivot. For this video, I'll be taking the last element as my pivot. See, for your convenience, I have written down the ratings of each guest above them. Now let me take H, my selected pivot. So here is the pivot. Now we need to have two sub-arrays around it. Let me mark it as 1 subarray 1 and subarray 2. Guest of the party that will be having value less than that of H would be in subarray 1, and the guest with higher value than that of H will be placed in subarray 2. Now let's start filling the two subarrays. H over here is having value 6. Is 7 greater than 6? Condition is true. So A will be inside subarray 2. Similarly, here 2 is less than 6. So B inside 1. Similarly, all the guests that will be having value less than that of H would be placed in subarray 1, and guests with higher value in subarray 2. So this is how, after undergoing one partition, our array would look like. I would name it as partition 1. Now H has been placed at its correct position. Similar partition would be applied for subarray 1 and subarray 2, and this process will keep on going until we'll be having a final sorted array. So this is how our final arrangement of guests would look like. So that was trailer of quicksort. Now let's understand quicksort with real array of numbers. As you can see, I'm having an unsorted array. Now we'll be applying the same procedure what we have learned till now to sort this unsorted array. So as we know, first of all, we'll be selecting a pivot element. In this case, I'm taking 6 as my pivot element. After first step, I'll be having my array arranged like this, and around it sub-arrays have been arranged. After the first step, my pivot is at its correct position. Now these two sub-arrays would undergo the same procedure as our original array, and these two procedures would take place separately. So in this sub-array, I'll be taking 1 as my pivot, and in this sub-array, I'll be taking 8 as my pivot. So that's how we'll be proceeding step 2. As you can see, in this sub-array, we had no element lesser than 1. 1 is having nothing on the left side, but 1 is having sub-array on the right side because 1 is the shortest. So this pivot and this pivot have found its correct position. Now these are the two subarrays obtained. As this subarray is having only one element, so we can now sort one element. So no sorting would be performed on this subarray, but in this subarray we'll be choosing 4 as our pivot. Again, after undergoing partition, 4 will find its correct place. See, 4 has found its correct place. Again, a subarray with one element. So the only subarray that would undergo the partition would be this subarray containing element 2, 3. Taking 3 as my pivot. So in this subarray there was nothing greater than 3. So it has been allotted a place left side and our only element has found its correct place. Now this subarray with one element 2 will not undergo any sort of partition and it would be allotted the same place. So my final sorted array would look like this, where all its elements are arranged in ascending order. So this was the working of quicksort, and quicksort takes place recursively. Now let's code it in Python. But before jumping onto the coding part, let's have a quick understanding of what is going to be our approach while coding. Suppose this is my array or subarray and I need to partition it. This is my lower index and this is my higher index. So in order to keep a track of elements to be placed in partitioning, I'll be first taking a counter variable whose value would be L minus 1, means the lower index minus 1. So C would point somewhere over here. The value of C would be 1 less than the lower index. So this is going to be our entire setup for the partitioning part. Now let's understand how partitioning would take place in the code. I would be taking the value at the highest index as my pivot and I would iterate this array or subarray from left to right. My iteration would be from left to right. So here I would be starting with 7. So I would check whether 7 is less than pivot. If the condition is false, then I would move to the next. My I would move to the next index. In this case, it will reach 2. So pivot is greater than 2. So what will happen? First, the value of C will get incremented, meaning C would point towards this place, the place of 7. Now 2 will be placed at this position and 7 would be this position, meaning both of them would be exchanging, swapping their places. After swapping, again, this process continues. Now checking of 3 would be done. Is 3 less than pivot? It is true. This condition is true. So again, the value of C would increment and C would now point towards this index. Now 3 and 7 would be exchanging their places and this process continues till we have all the elements less than that of 6 on the left side and greater than on the other side. As we will keep on gathering lower elements on this side, means on the left side, ultimately will reach to this stage. So this is the stage where we'll reach all the elements lower than pivot are arranged on one side, left hand side. The final thing that we have to do is to place this pivot after this lower subarray. So at this juncture, my C will be over here. For swapping, I will increment that C and that C would jump towards this place. Now the element at this position would exchange its plates with the pivot. So this is the ultimate position of the elements after our partition. Lower elements on one side and higher elements on the other side and pivot in the middle. For this entire partition process, two variables I and C will be using in the code. So now let's start our coding of quicksort in Python. First of all, I'll define a function to partition the array. This is my array pivot at the last index, the value at last index, and taking a counter variable c, value would be low minus 1, 1 less than low index. Now I would be taking a loop, I would be creating a loop for traversing through our array or subarray. Now comparison would be done. If my pivot is greater than the current value of iteration, then the following statements would be executed. Our counter variable c will be incremented by 1 and swapping would take place. So these are the statements that would be executed while iteration of our array or subarray from index low to index high. Now I would need to place my pivot at its correct position. Finally, I would be returning the position of pivot in my subarray, the correct position of pivot in my array. Further, I need to define a function to perform a sorting algorithm. If my lower index is less than high, then the following statements would be executed. The position of my pivot. For this, I'll be calling the partition function. This is the function that would be returning the correct position of my pivot. So as you can see, it's a recursive function. This is my index of pivot, which I gained from calling this partition function. And these are my two subarrays on which I'll be performing the partition process again if they satisfy this condition. So the entire logic of quicksort is now completed. Finally, I need to check whether my code is running properly or not. For this, I'll be needing an example array and calling this function quicksort. First of all, I'll be printing my original array, calling the function quicksort. After calling this function, my array would be sorted. Now I would be printing that array. This is my quicksort function. This is my partition function. And also I have taken an example array to check the working of my entire quicksort logic. Now finally I would be running this, check the output. See, this is my output. My original array is this, and after applying quicksort, this will be my sorted array. So our coding part is now completed.